Dear students, welcome to another lecture in Industrial Engineering. We were looking about ergonomics. So yesterday we saw about the some of the different types of controls. So we have seen. Now continuing from there, let us see the ergonomic considerations while designing the controls. Say the user and the machinery should be taken together when you are designing the controls. User as well as the control put together you should design, not the control alone. The control should be easily accessible for the operator, and it should be properly positioned. He should not be that he has to stretch to apply the control. It should be within the reach, it is easily accessible, and it should be properly positioned. A little thought about it should be given. Okay, then, and the shape of the control should be selected such that it satisfies the conformity with the anatomy of hands and feet. With the hands, what things we can operate, the shape should be in conformity to that. The levers, pedals, instruments, hand wheels, knobs, buttons, these are all the controls that we have seen. They must be located within the normal grasp or the range or the space at a suitable height and in front of the operator. Okay, any controls should be within the reach of the worker when operating the equipment. It is not that he has to travel a little distance, or he has to take one or two steps this side and that side, or he has to stretch his body, or stretch his arms. It should not be like that. It should be within the reach. Okay, the control operation should involve minimum motions. Okay, then the control actuator may be operated by light touch on a button. That means not, operating a button should not be more difficult. He has to press with much force and all. Should not be. And grasping and moving a lever, turning a dial, using a foot on pedal, and such things, should be with a little, with not much force, much exertion, he should be able to operate. Okay, the forces required to engage the controls should be within the capability of the worker. See, normally what we say, with the hand you can apply the 30 kg force or 300 newtons of force you can apply. It should be within that range. It should not be that he has to apply a force of 40 kgs or something. Then no, he may be requiring two hands to operate. And see, it should not be like that. It should be within the capability of the worker. However, these forces should not be too small or light also. You see, sometimes the controls are so light, with minimum, they unnecessarily or accidentally they get activated without any intention to activate. The foot pedals must be provided with suitably returning springs. You see, when we are pressing, after pressing they should come back. You put some springs there, either helical compression springs or torsion springs or some springs you provide, so that they'll come back. Okay, while designing controls, care must be taken to avoid eye, muscular and mental strains. You should give attention, muscular strain and other things, when much forces are to be applied. In the eye, it should not be some bright light or glaring in the eye, should not be. And mental strain should not be there. He has to do some calculations or apply much thought to it. It should not be like that. Okay, machine must be designed so that, machine means, here we are talking about the controls. Controls must be designed so that the worker can use both hands and feet simultaneously for operating it. It is not that only all the controls are given for the right hand and the left hand and the feet and other things are idle. It should not be like that. Distribute them in such a way, all the controls, so that all the limbs will have functions to do. Control should be painted in proper color to attract the attention. Normally, the red color is for a danger signal we use, and whatever is the accepted colors, those colors, it should be painted with. The direction of movement of controls should be consistent with the expected outcome. For example, moving the control lever forward should move the equipment forward. It should not be the reverse. We are pulling backward means it is going forward. It should not be like that. If you are moving forward, it should move forward. If you are moving to the right, it should move to the right. You may have seen in your toys, these remote control cars and other things. If you are the joystick, if you are pressing to the right, the car will move to the right. It should be like that. It should not be in the reverse direction. If it is like that, then what happens is, you will have to there should not be any confusion. If you are moving to the right, it should move to the right, like that. Control device is usually rotated in clockwise direction or moved to the right for on or increase. This is an accepted thing. If you are rotating something clockwise direction, that means you are increasing, say suppose the volume or something. The knob you are rotating the clockwise direction means it is increasing. The anti-clockwise means it is decreasing. It should be like that. But however, different movements are adopted for special circumstances. It should be there should not be confusion in the person's mind. Then ergonomics must be involved in fitting the tool or the control to the worker by designing it accordingly. So these are the things which we have to keep in mind. Now, specific recommendations for design of different controls. Now, let us see various functional requirements. The first one is push buttons should have positive some click sound, so that the operator will know, yeah, I have pressed it and some click sound came, that means it is positively I have applied the control. Such a feedback he should get. Okay, see, and knobs for continuous control can be shaped and color coded effectively and with the appropriate gearing, and provide a considerably flexible choice of adjustments. See, these knobs should be color coded, like maybe for a range of things. For this color, this much range it should be this color, this much range this color, like that. You should provide. Levers are commonly used as gear shifts, throttles, joysticks in positioning and tracking tasks. Then steering wheels are useful where large rotary forces must be applied, but they require more space. You see, if there is something can be used with the help of a button, just pushing a button, how much space it requires. Whereas if you are having like a steering wheel of the car or something, how much space it is occupying. See, steering wheel is taking more space. Okay, but anyway, they can apply large forces, whereas button you cannot apply large forces. Foot pedals have characteristics similar to the hand wheel, but they are for larger force applications. Then criteria for selecting a control member according to its specific use and requirement. You see, when you are selecting it, it may be on the basis of its functional requirement or the required speed of operation, with what speed you have to operate. You see, some of the controls you can operate very fast. Some you cannot operate so fast. Then depending upon the accuracy of control, depending upon the operating force, how much force you have to apply, and what range you have to provide, and what direction of control, convenience for the user, and all these things, these are the criteria for selecting the control member. Now, compatibility in design of control members used in machine. Identification of controls is important because operation of the wrong control can be frustrating and it leads to inefficiency. It may cause accidents. The identification of controls is done by different means. For example, by shape, by texture, by size, by labels, by location, and by operational methods. You will be able to you do the identification of the controls. Then controls having similar type of functions should be arranged together. See, you can group them in such a way that similar controls are together, but they are positioned with sufficient space between them to prevent any unintentional operation. Controls should be laid out and designed for easy and safe operation and to prevent confusion over allocation of control functions or direction of operations. You see, the important thing is, everything should be designed in such a way that it is easy and safe for operations. It should not be too closer or too farther apart. Everything should be in such a way that it is easy for the operator, and also the controls can be safely operated. Controls arranged together may be painted with different colors. Suppose in one place many controls are there, you can provide them each different color so that they will know if red color is there, that is for this, for green color is there, that is for this, blue color is there. You see, like that they can identify also. This method also leads to attract the attention of machine operators. They can easily identify and apply, and accidents or unintentionally they will not press the wrong controls. When operators have to move from machine to machine, having controls doing the same function. Suppose he is operating in two machines. One is a lathe machine, and the adjacent some other machine, say milling machine is there. You see, it is better to have same controls. In one place how the buttons are, the other place also the buttons are the same thing. There won't be confusion. Otherwise, in one place, if it is a push button, another place there is a lever. Then there will be confusions. As far as possible, it should be made to look similar. Okay, then the role of ergonomics in design of displays. Now let us see about the displays. You see, till now we have seen about the controls. Okay, now displays are the devices through which the user can receive information from the machine. See, display, unless we get the information, we will not know what is happening. A good display device is one which allows proper combination of speed, accuracy, and sensitivity of the display. It should immediate speed means immediately the response should be displayed, and accurately it should be displayed, and the sensitivity means even the smallest variations it should be able to display. Then displays are necessary for necessary extensions to man's senses and provide information needed by operators in making decisions and in effecting control responses. If displays, you see, sometimes even without the displays also you will be able to sense, but this will be a kind of for help. Suppose you see, without the speedometer you will not know that its bike is slowing down. But you know, you will know that. But you know, if you provide a speedometer and know if it is showing, oh, because you have applied brake, the speedometer reading has come from 80 to 50. You know, you'll be able to have a more accurate knowledge of the speed. Okay. Information presented by displays can be considered as a dynamic or static. So see, these displays can be dynamic displays, these can be static displays also. The name itself shows dynamic means, here it is written dynamic information continuously changes, whereas static, no, it doesn't change. Dynamic display is subject to change from time to time, like in case of traffic signals, they keep changing. The charts, it will be going up, down, it will be plotting and like that. Okay, then display devices can be mainly classified into two broad categories: the visual displays and sound displays or auditory displays. So first let us see about the visual displays. Visual displays means with the eye what you can see, that is the visual display. So depending upon the type of information provided by visual displays, these can be further categorized as qualitative and quantitative. You see, when you say quantity, it is the amount, numbers, numerals are involved here. Qualitative means it is more like how much, you see, call it the qualitative displays indicate only the condition or state without giving any values. If you want for values, you have to go for quantitative. So here is a image. It shows, you see, this dial is divided into three parts, divided at 120 degrees. Okay, so each sector is taking 120 degrees. So one sector is cold, one sector is warm, one sector is hot. Okay, now the display, this needle is showing hot. You see, it only shows hot. How much hot, what is the temperature, is it 70 degrees, is it 80 degrees, 120 degrees, 200 degrees, nobody knows. Okay, so it doesn't clearly display the exact value, but it shows only the it only indicates the condition or the state of the things. Okay, this is a circular display. Similarly, there is a straight display here. Here in the straight display, hot, warm, cold are there. Here a pointer is pointing and showing. These are like qualitative displays. Okay, so they can simply indicate something is on or off. For example, red, yellow and green lights are used for traffic signals. You see, but nowadays there also digital displays come. If red is on, for how much time. Nowadays they have put signals, time also, it will be countdown and timing will be there. If it is for 1 minute, from 60, 59, 58, 57, like that countdown, the digits also will be coming. But in most of the cases it is only just lights, red, yellow and green lights, and on-off indicators of home appliances also. If if it is a mixie is there, if it is on, it may have a red light blinking or red light lighting glowing there, so thereby it is on. If it is if the light is not there, then we will know that it is an off condition. Like that, we will know. Okay, so this is a qualitative display. And when you're talking about quantitative display, it shows some values, it shows numerical information, okay, about the machine or the equipment, so that the user will be exactly able to know what is the value or what is the number. So it can be displayed in pointer scale arrangement, for example, voltmeters, your voltmeter, ammeter, speedometers, watches, energy meters, they all show such kind of, it can be like a circular dials like this, semicircular or linear scale, horizontal, vertical, like this, this quantitative displays can be there. Now we have seen about the visual display. Now next is auditory displays. That means, that which you can hear with your ears. Okay, as compared to the visual displays, auditory displays can make monitoring performance is superior. Sometimes some signals will become, some sounds will become, some sound bites will be coming like that. Therefore these devices are suitable as warning devices. Something wrong has happened. Some buzzer will start blazing. Okay. See, following are some of the situations in which auditory displays are more suitable. You see, when a message is simple and short, just something, you see, even in your computer also you will see some new, or even in your WhatsApp some new messages come. So it can simply come, and without sound also it can come, but you will not notice, when it a little sound it comes, oh, a message has come, you will know. You see, it's a short and a simple message, and you are knowing that it is this. When the message calls for immediate action, also you can use this auditory sound. When the receiver moves from one place to another place, then you can give that sound. And when continuously changing information of some type is to be presented, then auditory displays you can put. Okay. Then information required before starting design of displays. You are as a designer, or a designer designing machines, or as a process engineer designing the process. When you are designing something, designing the displays, you have to keep this information in your mind. When you are designing displays, what you should do is, what type of information is to be transmitted, and what is the purpose of this information, the display that you are giving. So, and what type of display is to be used, whether it should be analog and digital, or whether it is some auditory or visual, what type of information you want to. Okay, nature of visual environment in which information is to be transmitted. What type of visual environment, what background colors are there, what foreground colors are there, what type of if it is display, means it should be seen. Okay. And then detailed design characteristics of the type of display chosen also, that information also you should have. Okay, now when we are designing the displays, what ergonomic considerations we should keep in mind? See, the ergonomic considerations in design of displays, you see, suppose a scale on a circular indicator is there. It should be divided suitably in a linear progression. You can simply put 0, 10, 20, 30 like that. You should not it should not be arbitrary, like you have put 0, then you have put 15, then you have put 20, then you have put 50, like that. It should not be there. It should be a linear progression, equally spaced. Why not, at every 10th division, why don't you put these lines like this, 0, 10, 20, 30. Then number of divisions between the divisions, number of subdivisions between the divisions should be minimum. See, subdivisions should be minimum. No, it should not be that so many divisions, and thereby you are not able to clearly distinguish what exactly the analogous value is. Then vertical figures should be used for stationary dials. Suppose that stationary dials are there, use vertical figures, whereas the radial oriented figures should be used for rotating dials. Then height of the letters, when I went to Hyderabad, there I saw the metro rail station. They have put station, the names of the stations. They have put in so small letters. From distance we are not able to see what it is. You see, on the road, if you are putting some signal, you should be able to it should be clearly read from distance also. Okay, and especially metro railway stations, it should be from far. The railway stations. If Jalgaon railway station, Jalgaon city is there, Jalgaon station is there. It is written quite a big font. Okay, the size of the font. Okay, you see here there is a formula. You see, it should be that numbers should be displayed greater than or equal to reading distance upon 200. Suppose you want to read it through see, it depends, from where do you want to read it. Do you want to read it from 50 meters, or do you want to read it from 100 meters or 200 meters? Depending upon that, you have to, with this formula, you can find out. So pointer should have knife edge with a mirror placed or located behind the graduated scale to minimize the parallax error. In physics you have learned about this parallax error. To minimize the parallax error, there should be a mirror placed underneath, and also a knife edge should be there, so that I will exactly know which is the division it is pointing. Okay, numbering should increase in clockwise direction. See, number should be as clockwise direction. As the hands in the clock, how they rotate in that direction. It should be increasing. 0, 20, 10, 20, 30, 40, like that. It increases. Okay, on a circular scale. And if it is a horizontal scale, from left hand to right hand, it should be. And if it is a vertical scale, from down to up, it should be upward. It should be. Okay, it should increase upward. Okay, distinction in display groups should be made with the help of color, shape, and size. Display groups. If you are making different groups, should be of different color, different groups should be of different shape, and different groups should be of different sizes. Okay, important displays like warnings, fire alarms, urgent attention, etc. can be made more effective by use of flashing lights or a light of varying brightness. Okay, these things can be done. Then the role of ergonomics. Now let us discuss the role of ergonomics in design of environment and safety. Ergonomics plays an important role in controlling the environment problems which adversely affect the performance of production. Working environment affects the man-machine environment. It affects the efficiency of the operation of the worker. It affects the health of the worker and also safety of the worker or the operator. Okay, working environment, we should pay attention to it when we are designing according to ergonomics. Okay, variety of functions are performed by human beings in industrial environment, such as controlling, supervising, maintenance work, and maintenance of the equipment, etc. So all these things he will be doing. Okay, most important factors affecting efficiency of human beings are heat, humidity, light, air movement, noise, acceleration, including vibrations. These are some of the things which will be affecting the efficiency of the human being. Okay, then now first let us discuss about the lighting, or you call it illumination. See, the amount of light required to enable the task to be efficiently performed depends upon the degree of precision required for the work. How accurately you have to do, depending upon that, the brightness of the illumination of that place should be there, and what is the time allowed to see the task. If you want to see it in a fraction of a second, it should be very clearly, it should be visible. Such kind of illumination you should provide. And if you have sufficient, if you allow some more time, then it may not be as brightly illuminated. And then reflective characteristics of the equipment involved and the sharpness of vision of the human beings. It depends, I say, it depends upon the age of the operator also. You say, because as human beings age, their sharpness of vision reduces. You should keep these things in mind, while designing the lighting and other things. The type of lighting and illumination depends upon the type of work being performed. You see, what type of work we are doing, the size of the objects, how big they are, big things or small. See, if you are handling one big barrel of oil or something, see, you may not need such kind of brightness. Whereas small, suppose you are assembling small parts of a wristwatch. You see, there you need proper kind of illumination. Okay, then the accuracy, the speed and duration of work, all these are the things on which the type of lighting depends. Then the surrounding area, including the walls, ceilings, floors and other objects, should be bright and more colored than the workplace. See, the walls, you see, there is a reason why people color their walls in white color. You see, it should be bright. Okay, the ceiling, the floor and other objects should be bright and more colored than the workplace, where the worker operator should be or should not be. Okay, anyway, see, the place where he is working, is operating, it should be it should be more illuminated. Lighting should match the needs of the task as per the illumination is concerned. Then glare causes discomfort. If something, if it's shining in the eyes, glare is coming. You see, that causes discomfort and it reduces the visibility of the task. Glare can be minimized by eliminating minimized or eliminated by carefully designing the lighting source. Suppose some sunlight is coming and it is falling in the eyes, or it is falling on the floor, and from there it is reflected to the eyes of the operator. Such things, the glare. Even when we are driving, car and other things, sometimes sun will be coming in the eyes. That's why they have just on the above the driver, they have some flap, which you can open and you can prevent the sun falling into the eyes. See, it can be eliminated by designing such things, and the positions of the lights or the place where they are working, and changes in the texture of the working surfaces. If it is brightly shining, if it is stainless steel, or if some such thing, it will reflect the texture and other things of the working surfaces. You can change, because the glare should not come. Then workers will become less tired if the lighting and color scheme are arranged so that there is a gradual change in brightness. The change should be gradual, it should not one place it is the lighting and color, in one place it is very bright, in the other place it is completely dark. Like, it should not be like that. It should be gradual. The lighting system should fulfill the following requirements: sufficient brightness, uniform illumination, a contrast between brightness of the job and that of the background, and no direct or reflected glare. These things you should keep in mind when you are considering the lighting. Then let us talk about the noise. Noise means what? It is the unwanted sound. Okay, it creates both short-term and long-term effects on human beings. If unnecessary some noise comes, is immediately man gives attention to it. Okay, so he loses concentration, and and it is, if a lot of noise is coming, it may have short-term effect, and it may have long-term effect also. Suppose continuously long-term, if it is there, some people even may go deaf. Okay, these effects may be internal or physiological in nature, resulting in the auditory system being unable to hear the sound, which may be in the form of work-related discussion between two or more than two machine operators, or instructions being given by supervisor or engineer to a group of machine operators. You see, if some big, lot of noise is coming, normally in the companies, you see, so many, see these pneumatic systems will be making lot of noise, and then hitting, banging, hammering, and all these things, machining, all these will be so many sounds will be there. So sometimes you will not be able to hear what you're saying. If there's some boiler or something is there, there will be sound there. All these sounds, so many sounds will be there. These sounds may make the people that if two people are talking, or if a supervisor is talking to his subordinates or to his workers, people will not be able to hear properly. If you don't hear properly, how will you be able to perform the work? If you properly don't understand what is expected of you, how will you be able to perform the work? So this noise is a big the thing that you have to consider. Okay, noise produces three effects. It produces annoyance and loss of hearing, and it may reduce efficiency. You see, he may be annoyed, or he may, his efficiency may be reduced, or it may cause even loss of hearing also. Okay, these are different, the three effects of noise. Then high pitched noises, interrupted and sudden noise, and unexpected noise. These things produce maximum discomfort than steady noise environment. If it is steady throughout 8-hour shift, same noise is coming, after a few days, he may get accustomed to it. But some sudden sounds are coming, like they will have they will produce more discomfort. Okay, then experimental studies indicate that the workers do not work slower when exposed to noise, but it appears that loud noise causes them to be less accurate. See, it is not that they are slowing down, but this noises, what they are doing is, they are not working accurately, and they may do some mistakes while doing the work. If the noise level is too high, it can be stopped at source by better maintenance equipment, or plugging ears, and providing sound insulating walls, and other things. You have to design some means by which, see, if it is a one-day phenomenon, okay, you need not worry. But if it is constantly coming, you have to see some soundproofing, insulating you can do, or you can provide earplugs and for the operators, or you can design the systems in a better way that the sound will reduce. Then sudden loud sound, which are entirely unexpected, can lead to increase in blood pressure, sweating, muscular contraction. Even these physical problems also may come. Now let us see the recommendations to reduce noise. Where the problem is the talker, speech training may be necessary to correct those aspects which are at fault. Okay, if somebody is talking, see, if it is a human being, speech training can be given. Where the noise is present and has been identified as a problem, it should be reduced at the source itself by doing better maintenance of the equipment. If some machines, some old machines are there, means they will be making so much noise. New machines may be operating in a smoother manner. Okay, for the old machines means you may have to provide proper lubrication. You may have to provide grease and oil and other things, by which this noise at the source itself, it can be reduced. Okay, excessively noisy machines, equipment operations should be isolated by constructing enclosures so that amount of noise transmission beyond the exposure is reduced. Suppose some machine is making a lot of noise, that machine alone can be isolated and put in we can it can be put in an enclosure so that the sound will not be disturbing the surroundings. Or the other way around you can do is the other people can be put in a enclosure and this machine can be kept out, like that also you can do. Okay, then the use of baffles, those things that absorb sound, and sound absorbers, and acoustical treatment of walls, ceilings and floors can also reduce sound reflection. Then in severe noise situations, workers should be provided with personal protective devices such as earplugs, earmuffs, helmets and other things. So these are some of the things by which you can reduce the sound. So today we have seen in this topic of design of environment and safety, considering the ergonomics, we have seen about the lighting and we have seen about the noise. Okay, so today we will stop here and we will continue with our discussion on ergonomics tomorrow also. Thank you.